This question is in section 1.8. I believe it's question number 18 in the homework assignment. It's asking us to write a linear function. We've got some straight line depreciation that helps spread the cost of new equipment over a number of years. The company's copy machine will value, after 1 year, its value will be $13,500. After 4 years, it will be $4,800. So we want a linear function. Okay, so what I notice here is that I have information that groups, that's ordered pairs, really, 1 year value and then the 4 year value. So I'm going to use this here to type my information. After 1 year times the input, the output is 13,500. And then 4 years later, input of 4, the output would be 4,800. So I want to organize my information as ordered pairs. All right. Now that I have the ordered pairs, when I write the equation of a linear function, I know that it's supposed to be of the form y equals mx plus b. I need to find m, and then I'm going to need to find b. Right, so let's go ahead and find m first. I know that the equation for slope is y2 minus y1 over x2 minus x1. So second y value, or the final output, which is 4,800, minus the initial output, which is 13,500, over, and then the final input, which is 4, minus the initial input, which is 1. Right, so I've got that. Now I'm going to use Desmos to help me simplify this. And I can type the whole thing in just like that. I don't think I can copy and paste it in there. So I'm going to move this over so I can still see it and flip over to a Desmos tab. My m value is going to be fraction. So we said 4,800 minus 13,500 over 4 minus 1. All right, so we came out with an m value of negative 2,900. Sometimes we need to interpret the slope. So what this slope means is that the value of the copy machine is decreasing or depreciating by $2,900 per year, since the input values are in terms of years. That would be the interpretation of that slope value. All right, so I know the m value now. So I'm going to rewrite my equation here with this number in for m. And next, we're going to solve for b. All right, so just copying and pasting again here. I'm going to solve for b, and to solve for b, I need to take one of my ordered pairs and plug it in for x and for y. It doesn't matter which one, I get to choose. Whichever one I'm feeling looks nicer. I'm going to pick the top one. So the top one has an x value of 1 and a y value of 13,500. All right. So this gives me 13,500 equals negative 2,900 times 1 is negative 2,900 plus b. And then if I'm going to solve this, I'm going to add, because it's negative, to get rid of the 2,900, I'm going to add 2,900 to both sides. All right, and so that's going to give us 13,500 plus 2,900. That's going to give us 16,400, equal to our b value on the side. Those negative 2,900 and 2,900 added to 0, just got b left over there. All right, so grab our line up here, copy it again, and then I can paste it and insert the value for b, which I now know is 16,400. All right, so that is the equation. So I'm going to go back over to my MATLAB tab, and that should also match the equation that was presented up there. So that is our solution, and that's how I come up with it. To finish the question, in part B, they're asking me the salvage value of the copy after 5 years. So what would it be worth after 5 years? All right, and so I can input, since 5 is time, I can input x equals 5 into the equation. So if I take this equation, again, just copying it, moving it down, and inputting a 5, what I need to do is take negative 2,900 times 5 plus the 16,400. And so it turns out that the value of the copier after 5 years is $1,900. $1,900. There we go. Okay, so that answers the question. I can make a separate video to show you a different way to solve this one, but this is how we've been working on them in class. We've been working on them using slope-intercept form, and our first step is always to find the slope no matter which method we use. And then we've been using this equation with the slope plugged in with an ordered pair in for x and for y so that we can solve for the b value and then put our full equation together.